Hi, still on cyclic quad, Euclidean geometry. This is very important. It's cyclic quad is very important. It plays a huge part of Euclidean geometry, a huge part, right? We said when you're defining cyclic quad, you know, we have four chords that touches the circle four times. And let's say now you have like this for some reason, right? It just went outside the circle. Voila. Okay, so if like let's call it A, this is B, this is C, this is D. Let's call it 1, 2 because we have different angles already. Cool, right? And I want you to remember one of the theorems that we had. Remember one of the theorems that we had when we were defining tangent, right? Theorems on tangent. When you said, I'll write it very small, very small. Please go back to our previous video. Look at the previous video you had on this one, so that you can just remind yourself. But if you've been following up what I've been working on, you remember this angle here is the same as this angle, and the reason was the angle between the chord and the tangent, and then the interior opposite angle, they're the same, okay, as an exterior angle. Remember that? Now we're gonna apply the same context with this one, but on cyclic quad. So I'm sure you guessed it right. So meaning that this angle is the same as this angle. You see the similarity, right? And exterior angle, the exterior angle is equal to the opposite interior angle, right? So the reason is this is exactly what I just said. Exterior angle of a cyclic quad, right, is the same as the opposite interior angle of a cyclic quad. You don't have to write the whole statement. You can just write that. Exterior angle for cyclic quad. That's your reason, right? So if you have B1, so meaning that angle B1 is the same as angle D. That's what it means. If this is X, therefore this is X. The way if this was Y, then this will be Y as well. My Y is very funny. This is Y as well. Okay, so the reason for this one here is exterior angle of a cyclic quad. Exterior angle of a cyclic quad is the same as that one. You cannot have the same, because remember the reason from here is an angle between chord and tangent. The reason for this, because of the chord, so we have the chord and here the tangent. But here, this is not a tangent. It's what? It's just a line that subtended outside the circle. And then we have a chord here. Now we cannot say an angle between a line and a chord and then you not have a full theorem. But this happens when you're in a cyclic quad. So the exterior angle is the same as the opposite interior angle. And then the reason you can just write it that way this way. Exterior angle for cyclic quad. Simple, straightforward. Let me give an example. Example will make things into perspective, I guess. Circle quad. Okay? And then we have, this is extended. Guess what? This is 60 degrees. And then you're told A, B, C, D is a cyclic quad. And they want you to find C2 and C1. So the question is, find angle C1 and angle C2. Angle C1 and C2. And what do you know about cyclic quad, right? We know that opposite angles are equal to 180 degrees. We know that, right? We know that angle A plus angle C2, these are opposite angles, right? They should be equal to 180 degrees. This is what you know. This is what you're looking for. This is the solution. The solution starts here. Angle A plus angle C2, they equal to 180 degrees. And the reason for that, we had the reason from our previous video. Please check it out how we get here. But let me just write the reason. It's opposite angles of a cyclic quad. Simple as that. Opposite angles of a quad, the supplemental, they equal to 180 degrees. Cool, right? So we're looking for C2. So how do you get C2? So from here we have A is 60 degrees plus C2, this is 180 degrees. Therefore, C2 is 180 degrees. Take 60, put the other sides, become negative 60. C2, so angle C2 will be 180 minus 60, that is 120 degrees. So now this is, this is 120 degrees. Cool. Now let's look at for C1. C1, I wanted to use the theorem, this theorem here. I know there's another way of doing this, but I want us to use this theorem, the extended angle of a cyclic quad. This and this are equal. So C1, using that theorem, so C1, which is this theorem, this angle is equal to that angle. So it's equal to 60 degrees. Say the same thing. This and this are equal. So this angle and this angle is equal. C1 is equal to 60 degrees. And the reason for that, this is the reason. Exterior angle of a cyclic quad. Of a cyclic quad. Exterior angle of a cyclic quad. That's cool, right? We just applied two theorems in one circle, which is great. And that's what you're going to be doing, actually. The entire Euclidean geometry, you'll be applying all of this theorem that you just learned on one question, one circle, trying to find x and y. It's like a puzzle. Very nice. Very, very nice.